Welcome to Section 6, Testing Actors. In the previous section, working with Akka cluster, we were introduced to the Akka cluster and touched upon topics such as remote actor, routing on the cluster sharding, and cluster singleton. In this section, we will shift our focus to testing different aspects of Akka. We will test our actors, parent-child relationships, and finite state machines. Finally, we will take a look at multi-mode tests. Let's start with the first video, how to test an actor. In this video, we will take a look at the different styles to test the actor, and we will start with coding. Akka comes with a dedicated module for supporting tests, the Akka Test Kit. Let's add the Akka Test Kit module and Scala test to our dependencies. Here is the counter actor, which handles the messages increment, decrement, and get count, and has a count variable. We want to implement our tests for this actor. Let's create a counterspec class that extends the testkit class, which gives us the basic tools we need to work with actors. This includes access to the actor system, as well as helper methods for dealing with responses from actors under test. We will be using Scala test in this video. However, it's possible to test Akka using different testing frameworks. The test kit provided by Akka is test framework independent. In case of Scala test, we need to extend the flat spec like trait to get the general test syntax available, before and after all to be able to hook into the suite's lifecycle events, and we'll use the must matches to actually write our assertions using the X must do something style. First, let's shut down the actor system after all the tests finish. For this, override the after all method. We will use the shutdown actor system method from testkit as our actor system was created by the test kit called system. Now, let's add our test unit. First, let's define our sender actor that will send messages for our counter actor. We will use test probs, which allows us to send messages and expect response messages. Next, let's define running an instance from our actor, send an increment message, and then get the count message. Now, our sender should receive the response of the get count message. Test probs provide some methods that help us to expect the messages. Let's use expect message type, which expects a message of a specific type. Our response should be int. If the sender receives a message with another type, this expectation will fail. Finally, let's assert on the value of the state. The state must be equal to 1. Let's run. Great, it passes. Let's implement a test unit for increment messages only. We do not want to set up a test probe each time in a test. We can instead use the implicit sender trait, which makes the test kit able to receive messages directly. The test kit contains the test actor, which contains expectation methods such as test prob. When we mix with implicit sender, this test actor uses as a sender for any message in tests. So let's define a running instance of a counter and send an increment message for it. When the counter actor receives an increment message, it just changes the count and doesn't send a response to the sender. So, let's expect that we didn't receive messages during that 1 second slot. Here we are using the implicit sender. Let's run. Great, it passed as well. Now, let's add a test unit for the decrement message like the previous one, but we will send a decrement message and also expect no message. Let's run. Great. Now, let's add a test for get count, but we will use an implicit sender and send the get count message, only to make sure our actor starts with 0 on the count variable. So, let's add an instance of the counter, send the get count message, and expect we will receive the message containing 0. Let's run. Excellent! Now let's add another test, where we will send the increment, decrement, and get count messages. Let's create an instance of the counter, then send 2 increment messages, send a decrement message, and also send another increment message. Now, the counter actor should contain a count that equals 2. So, let's send the getCount message and expect to receive a message that contains 2. Let's run. Excellent! All tests passed. At the end of this video, we implement a different unit test for each counter actor. We use the recommended style from Akka. You can check the test documentation from here, and you'll find another style for testing called synchronous testing, which uses test actor ref, but it's potentially exposed for race conditions and should not be used. See you in the next video, where we will test parent-child relationships.